Okay, good afternoon, my dear students. I am recording this video so you get to work into this exercise which was done during board work for the ones who actually missed the class. And since I am homeroom and stuff like that, so I wanted to, yeah, get prepared for what's coming in the exam. And also, I wanted to practice if you were in my class. So into this board work, it was pretty simple to work into this exercise. It says specifically, if 11 liters of oxygen at STP are heated to 412 Celsius degrees, what will be the new volume of the gas if the pressure is increased to 1,520 millimeters of mercury? So in the first place, step number one you're supposed to follow is basically getting to actually read the exercise and try to underline the most important information. For example, it says liters of oxygen, so that's the volume, that's some sort of volume, and says STP. So STP is a standard temperature and pressure. So you know that the standard temperature is 273 Kelvin and the pressure is 1 atmosphere, or which is the same as saying 760 millimeters of mercury. And you see you have then some variables. So 11 liters is the volume, standard temperature pressure that could be two variables, which is the temperature and pressure. And also it says it's heated to 412 Celsius degrees, which is another temperature, you see. And also it's asking for what's going to be the new volume. So you underline that because you're looking for the volume 2, since you've got the volume 1. And then they're giving you the pressure 2. So that will be the next step, reading the information carefully. And after that, you're going to proceed to get to write the data there. To write data there, you just put in a column the variables and the equivalences you just obtained by reading what's explicit saying there. So you copy that. As you can see, the volume, it says volume 1, 11 liters, and also it's asking for volume 2. That's what I can read there. It says standard temperature and pressure. So pressure 1 is 1 atmosphere, as you can see here. It says 1 atmosphere. And also I passed the atmosphere to 760 millimeters of mercury because I can do that. And why is that I did that? Because I can see that in pressure 2, I have it in millimeters of mercury. Also, you could have it everything into atmospheres. In both cases, it's still correct, no problem at all. And it says that the temperature 1 is 273 Kelvin because I know it says a standard temperature. And now it's moving for temperature 2, which is 412 Celsius degrees. So I'm passing it to Kelvin because that's, as you know so far, and whenever you want to use gas laws, you're supposed to pass everything to Kelvin in terms of temperature. That's very important for you to remember. And it says, what will be the new volume? So you're looking for volume 2, and definitely they gave you the pressure 2. So remember, step number 1 was reading the exercise, locate the variables, then write the equivalences for the variables so you know what are the variables. And for C now, I have B1, P1, T1, B2, P2, T2. I don't have P2. So definitely what you have to apply there is the combined formula. So you write the formula you're going to use and also locate there the variable you're looking for. So that's why I have enclosed volume 2. And then the next step will be solve the equation for the variable you're looking for. So in this case, I have solved the equation for V2, which in Spanish is called despejar B2, or solve the equation for V2. And once you have solved the equation, only when you have solved the equation for the variable you're looking for, you're going to specifically locate the values obtained from the data. So instead of volume 1, you put 11 liters, 760 millimeters mercury, the temperature in Kelvin, and T1, T2, and the pressure. And then when you have, as you can see, I wrote all of the units for each variable. So I make sure they cancel up. And at the end, I am going to remain with liters, which is what I'm looking for volume. So in volume 2 would be that the answer, 13.8, if you insert those values into the calculator, and that would make it. Since we're talking about oxygen, the answer is going to be liters of oxygen, and that would be the answer for both works. So that would be the first idea. Get back to the video if you want to get started again. So basically, that will be an idea for practicing with the combined formula for gases.